For decades, we've been studying our sun's magnetic field, the invisible force that drives space weather and protects or threatens life on Earth. But what if I told you that everything we thought we knew about the sun's magnetism was only half the story? Today, we're diving into a groundbreaking discovery that's forcing scientists to rewrite the textbooks on solar physics. Researchers at the U.S. National Solar Observatory have made a shocking discovery. Using advanced computer simulations, they found that our sun's magnetic field may be twice as strong as we've been measuring. This isn't just a small error. We're discussing a fundamental misunderstanding of one of the most important forces in our solar system. But how could we have been so wrong for so long? The answer lies in the limitations of our most sophisticated instruments. The culprit is the Helioseismic and Magnetic Imager, or HMI, aboard NASA's Solar Dynamics Observatory, our primary tool for measuring the sun's magnetism. The HMI has been our eyes on the sun since 2010, capturing detailed images of solar magnetic fields. But here's the problem. Instruments don't just measure reality, they interpret it through their limitations. Think of it like looking at the world through tinted glasses. You see something, but not the full picture. The HMI has been systematically underestimating the sun's true magnetic strength. The researchers discovered this by running sophisticated computer simulations, essentially creating a virtual sun with a known magnetic field, then modeling what HMI should detect versus what it actually would detect. Here's how they cracked the code. The team started with a known magnetic field strength, modeled sunlight passing through space, and then recreated exactly what the HMI instrument should see under perfect conditions. The results were stunning. After applying their corrections, the simulated magnetograms showed solar field strengths roughly double what HMI currently detects. This wasn't a small calibration error. This was a complete revelation about the true power of our nearest star. Now, you might be wondering why this matters. The sun's magnetic field isn't just an abstract scientific concept. It's the driving force behind space weather that directly affects our modern world. Solar storms driven by magnetic field interactions can knock out satellites, disrupt GPS navigation, interfere with communications, and even cause massive power grid failures. Remember the 1989 Quebec blackout? A geomagnetic storm left 6 million people without power for 9 hours. And it's not just infrastructure. Astronaut safety depends on accurate space weather predictions. If the sun's magnetic field is twice as strong as we thought, scientists must rethink their solar storm models and space weather predictions completely. The good news? This calibration method isn't limited to just one instrument. The research team says it could be applied to other solar observatories, including ground-based networks like GONG. This breakthrough offers a new way to adjust decades of historical data, potentially revolutionizing our long-term understanding of solar magnetism and improving protection for future space exploration.